Welcome back to Algebra 1 Honors. This is the second part of Lesson 5-10. Two more types of grouping, using grouping to factor. Okay? Now, this looks like a horrible problem when you first look at it. But if you just take a minute and look all the way across, I think you can see at least some of the things you're going to have to group together. Here we've got a PQ. So if we have a PQ term, that means we need to be able to group together a P squared term and a Q squared term. So we're going to take the P squared, we're going to put that one in the middle, the 2PQ, and here's our Q squared right there. Okay, so we've used this term, this one, and this one, and we're going to group those together. Okay. Now, what do we have left? Then we're going to say, okay, what we have left is minus r squared plus 2r minus 1. Okay? And to group them together, I'm going to take this minus out. So I'm going to make it a minus r squared. Take a minus out of this, we get a minus 2r plus 1. Now, convince yourself, if you multiply back through, you get minus r squared plus 2r minus 1. Okay? You can't just stick parentheses there, because pulling the minus out changes everybody's signs inside the parentheses. Okay? So now we have this. We have p squared minus 2pq plus q squared minus another trinomial there. Now hopefully you can see that by grouping this way, we have two trinomials, and we can factor each one independently. This one, let's see, factors into p minus q times p minus q, right? Because we get p squared minus 1pq minus 2pq plus q squared. And then over here we get, this factors into r minus 1 times r minus 1. Okay. So p minus q times p minus q is p minus q squared minus r minus 1 times r minus 1 is r minus 1 squared. Now we have one more step. We can't stop here, because now we have the difference minus of two perfect squares. So like x squared minus 4, right? We're going to factor into the square roots with a plus in the middle and the square roots with a minus in the middle. So we have p minus q goes here, and p minus q goes here. Okay? And then r minus 1 goes here, and r minus 1 goes there. Okay? So square root plus square root times square root minus square root. Now then we need to simplify what we have in parentheses. There's a plus here, so we actually have p minus q plus r minus 1. So let's write that here. P minus q plus r minus 1. And then over here we have p minus q. And this minus right here is going to change the signs inside. So we're going to have minus r plus 1. Okay? And we're finished. So we had to group into two trinomials, then factor each trinomial, and it just turned out they were perfect squares. And then we had the difference of two perfect squares. So there were a lot of steps to this problem. Make sure you don't stop short, because a lot of people would get to here and go, oh, I'm done. Okay, well, you have one more step left to go. All right, let's look at the next one. Let's see our last problem here. Our last one is going to be m squared minus 9n squared plus 9 minus 6m. Now, you might say, well, in the previous problem, we grouped the m squared and the n squared together. But what gives me a hint that I'm not going to do that here is there's no n term. There's no linear term where the m and the n have a 1 as their exponents. Okay? So I'm going to look again and say, okay, what if I grouped all the m's together? So I have m squared minus 6m. Group these two together, and then group the n's together. Let's see, I've got minus 9n squared plus 9. Now again, I can't just stick parentheses here. Okay? If I want to put parentheses here, like this, I have to change this sign. Okay? Because remember, if we redistribute, we're going to get minus n squared, and a minus times a minus will give me my plus 9 back again. Be very careful. That's what will get you there. So now we have this. Okay? And what can I take out here? Well, I can factor an m out of here, and I get m minus 6. Okay? And over here, I can factor out a 9, okay, and I get n squared minus 1, okay. Now, I can factor this one step further into n plus 1 times n minus 1, and I get m. Okay, like so. And that's my factorization for that problem.